Well, guess who's back? Look at us, huh? I feel like it has been far too long since we have been in the classroom, but I am excited to kind of get our unit 2 more fully underway. We've been doing a deep dive on the periodic table, and what I'm going to do is offer some lecture. And if you have your note catcher, this entire space is designed for you to fill this in and use it however you see fit. I'm going to talk through while you guys are going to capture notes from my lecture. I'm going to be talking about the S block. And so your coloring will be in this category as well. What I'm going to do, and don't forget helium too, I'm actually going to go with the bigger version. And so as I color in my new blank periodic table, I will be talking through some of the features of the S block. So follow along, pull together whatever information you think is important, and then we will bring together all the information that you and your peers have pulled in order to have some discussion with each other in class about what we've learned. So let's go ahead and get started. Now, when I think about the S block elements, I think about the reliability of chemistry, because here we have certain clear rules that we follow in order to predict things about the S block. But there are also, as in real life, exceptions to the rule. So let's talk about some of the things that we would call trends. So any of the elements that we find here in this S block, we consider very highly reactive, meaning that they engage in chemical reactions readily and vigorously, I think is a good word to use, because of their valence configuration. Now, we've talked about this before, but I just want to emphasize a rule which we call the octet rule. In other words, it's the rule of 8. You know, an octopus has 8 legs, an octagon has 8 sides. The octet rule says that atoms, want to have 8 electrons. In their journey to get to 8, oftentimes, elements in the S block are far more likely to get rid of electrons in order to get to 8. And we'll start to explain that when we do some pictures. But let us say that elements in this family, this group 1 elements, they all have 1 valence electron. And these elements here, the group 2 elements, including helium, let me get that one in, have 2 valence electrons. Now, we're going to explain this further, but trust me when I tell you, it makes much more sense for an atom to get rid of 1 or 2 electrons than it does to try to bring on 6 or 7 additional electrons. And like I said, I'll explain that a little bit later. But for now, knowing that all of the S block elements have 1 or 2 valence electrons is important to know. In terms of their color, virtually all of them are gray, and they are all metals. And we could also say that they are not hard, right? They are relatively soft metals. In other words, for example, if you took a small block of sodium, you would be able to squeeze it like butter and manipulate it with your own hand. So it's not a very hard metal. But there are 2 exceptions up here, hydrogen and helium. Even though they are S block elements, they're not metals, and they are both colorless gases. And so we'll get into more of these exceptions as we go. But pretty much the rest of them are colored gray. They're highly reactive. They have 1 or 2 valence electrons. We've talked about that. We consider them soft metals, and so that's good to know. And they, as we mentioned, relatively easily give their valence electrons away when they're engaged in chemical reactions. In terms of the uses, some of you guys have received these elements, and so you guys already know, for example, lithium here is heavily involved in electronics, in particular batteries, rechargeable batteries. These 4, sodium, magnesium, potassium, and calcium, are all what I would call biologically significant elements. In other words, something like potassium, you may or may not know that bananas are a great source of potassium for the human body. Calcium is the element that makes bones strong. Okay, sodium is used in a lot of muscle contraction. So it's important to know that even though you are a living body, you actually have metal inside of you, and it is important that you have that metal in order to maintain a strong body and to keep yourself healthy. Okay, so these are some of the features of the S block. And of course, I want to make sure I get my helium in here too. And so based on what I've discussed, what I want you to do is to go back and re-listen if you have to, but identify those items that I discussed, which are properties or characteristics of the S block, and go ahead and jot them in your note catcher. And then when we get back together as a class, we're going to talk about what did you get and what did you get. Also, keep in mind, I have other sources. I would encourage you to go to Google, go to YouTube, and get some additional information that you can bring to the class for the benefit of everybody else. Now, I am also going to talk about the D block elements, which are down here. Okay, and so I'm going to go ahead and color those in while we discuss the trends. So when we think about D block elements, you guys, we're really thinking about the typical metals that you are usually familiar with. So when you get to thinking about, for example, the metal that's at the bottom of a desk, on the legs of a desk, for example, metal that is found in silverware for your forks and knives and spoons. When we think about metal that is used in coins, for example, virtually all of those metals and the characteristics of those metals can be found here in the D block. Okay, so when we think about D block elements, we're thinking along the lines of those kinds of metals that are good conductors of electricity. For example, copper is what you will find in almost every wire where electricity runs through, whether it is copper in your headphones or the wire that's in your your stapler or your charger, the wire that connects your TV to the electric outlet, or the wire that's in your refrigerator. All of those wires are generally made of copper because they conduct electricity. They allow the electricity to run through pretty easily. These metals we also consider malleable. Malleable is a term that means that it can be pounded or smashed into thin sheets. So, for example, silver and gold are metals that are used often in jewelry, for example. So when you think about that, you think about metals that can be pounded into sheets or rolled into wires. That's what ductile means. We also think of these metals as dense, which means they're hard. Okay, so for a pound of feathers isn't very hard, right? A pound of butter is not very hard. A pound of water was not very hard, but a pound of iron, that's going to be hard. And you sure don't want to get hit by a pound of iron, okay? Because it will hurt. So when we think about metals, we think that they're also very dense. Now, some of the other things that you think about, for example, nickel over here, or zinc, for example, are, what's the word I want to use? Shiny. The technical term, I think, is luster. Okay, and so that's something else that we find typical among metals. They all have a shiny sheen to them. They reflect light, if that makes sense. And what else? They have a very high melting point. In other words, these metals aren't going to melt in room temperature, right? They're going to stay reliable and solid. It takes a very, very high temperature to turn these metals into their liquid form. Okay, and so that's something that you should also keep in mind, which is good, because if we're using a metal, for example, to cook food, we don't want the pot to melt into liquid when we're trying to boil water. You understand? And so the idea of having a material that has a very high melting point is very good in certain circumstances. Let's see, what else can I tell you about D block elements? They're generally gray in color, but if you look carefully at these, you can probably predict which elements are not gray. And there's some of the ones that you're already familiar with, which is why we use them so often. For example, copper has a classic brown color. And what you also know about copper is when it rusts or tarnishes, it turns this very cool, like green, teal kind of color. Gold is another one. Gold is a gold colored metal. Okay, it's what makes gold extremely unique. So those are two particular exceptions. What we also find, and the reason that these elements, we tend to call them transition elements. I'm not sure if I mentioned this before, but group 1 elements, this group is what we call group 1. are called alkali metals. This column, group 2, I think it's not including helium, but these group 2 down here are called alkali earth metals. And then this entire section, all of these D block elements, we call them transition metals. And the reason that we call them transition metals is because they can have multiple oxidation states. Now, you may not know what that means right now. I'll teach you what that means later, but just know that these are the list of properties that I want you to capture when you make your notes, and then we'll talk about it in class. All right. So even though they have multiple oxidation states, they are stable elements, and they can participate in all kinds of chemical reactions. And so these elements do a lot of very interesting chemistry, and we will get to those as we continue our deep dive. Okay, so I'm going to leave it here. If you need to, go back and review what are some of the properties I discussed about the S block elements, and what are some things about this family or this group that are unique to this group, because I may have you compare them. And then the D block elements, what are they generally in terms of color, in terms of melting point, some general characteristics. And then I will be asking you about some specific exceptions. For example, some that have different colors or a different state. I'll mention this as I close. Mercury is actually a liquid at room temperature, unlike all of the other elements. And so we'll get to that a little bit more later. All right, so hopefully you found some good information. Bring that back to class, and we'll talk about it when we're back live. All right, guys. Peace.